This presentation will give information necessary to model the double pipe heat exchanger utilizing the ChemCAD simulation software. We're going to model a heat exchanger, in this case a double pipe heat exchanger, with a tube diameter of 0.75 inches, shell diameter of 1.5 inches, total length of 36 inches. Our inlet water temperature for this particular heat exchanger is 150 degrees Fahrenheit. Cold water inlet is 55, and we measured a hot water outlet temperature of 145. In ChemCAD, we're going to use a heat exchanger system where we have a hot water inlet, in my case stream number 1, a cold water inlet, stream number 3. We're utilizing a heat exchanger that allows two inputs, and then we have the hot water outlet followed by the cold water outlet. We input our hot water stream at 150 degrees Fahrenheit. We'll assume that the pressure is 30 psi and its flow is 2 gallons per minute. To enter data in gallons per minute, we first set the weight fraction of our component unit for water equal to 1, and this will allow us to select this as our total flow unit. Note that you must have STDL for the gallons per minute. Similarly, we will do the same thing for our cold water inlet, where it's 55 degrees Fahrenheit, 60 psi, and 4 gallons per minute. The next thing we need to do is specify how the heat exchanger is going to operate, and we do that by double clicking onto the heat exchanger, and the following menu comes up. Here we want to specify the outlet temperature of stream 2, that is our hot water outlet, so that it is at 145 degrees Fahrenheit. And we do that by going to the temperature stream 2 in the heat exchanger menu and entering 145 Fahrenheit for this particular stream. Once that's done, we hit OK, and then we're ready to run our ChemCAD program. And once that's done, we run it, and then we look at our streams leaving the heat exchanger after it's been run. Our stream number 1 was our inlet hot water. It's now coming out as stream number 2. Its temperature is the 145 degrees that we've specified, and our outlet cold water temperature using this heat exchanger comes out to be 57.5 degrees Fahrenheit. The next thing we want to do is use the rating mode of ChemCAD for heat exchangers, and this is done by first selecting the heat exchanger and then going up to the sizing menu, select heat exchanger and double pipe heat exchanger. Our next menu that comes up will be to select the stream that's entering on the tube side. Our current configuration has our hot water coming into the tube side, so we'll click OK and then tell it that stream number 1 enters into the tube, and click OK on that. Then we're going to tell it that our current configuration is our cold water and hot water are flowing in concurrently. You can select counter current if your heat exchanger is configured that way, and then select the OK button. And it comes up with the enthalpy diagram where the temperature of the two streams are plotted against the change in enthalpy. Here we see the hot stream in red, where it starts in at 150 and exits at about 145, and our cold stream, which is in green, goes from 55 degrees Fahrenheit to approximately 58. Our general specifications menu then appears, and we will select rating mode as our calculation mode, and the geometry type will be straight tube, and we will see that it has our tube side as our hot water inlet and shell side as the cold water inlet. The process type in our case is called sensible flow, and that means that we are going through a temperature change but no phase changes. If your current heat exchanger configuration does have a phase change, then you can change that process type accordingly. Our next menu now has us specifying the tube dimensions. Our particular heat exchanger just has a single tube, and we would put in the outer diameter, in our case 0.75 inches, which calculates out to be 0.0625 feet. Also our wall thickness is entered, along with the tube length of 3 feet. And we'll use the default roughness factor given to us as 1.34 times 10 to the minus 5 feet. And our finned tube code would be plain tube. We now are asked about our shell side, and it is 1.5 inches in diameter, which is 0.125 feet, and we're only using a single exchanger in parallel and one exchanger in series. Clicking OK, it asks us what the nozzle diameters are for the tube and shell. We will try first just the dimensions of the tube and shell, put in the 0.0625 feet for the inlet and outlet for the tube, and 0.125 feet for the shell inlet and outlet. And our material specifications, we will be using copper as our tube material, and we would select OK. We're now going to hit the calculate button on ChemCAD and see how this works out. And a menu appears saying that we have a warning that our shell inlet nozzle is too large, and they set it to 0.8 times the shell diameter along with the outlet nozzle. And this is not a big factor in our particular case, so we will allow it to do that and click yes to continue. Now we come up with the view results menu, and we have a number of options we can choose. The one that we're going to select is the tabulated data menu. The tabulated analysis gives us quite a bit of information regarding everything going on the tube and shell side. We're given the average velocities for the different streams, calculated heat transfer coefficients, Reynolds numbers, pressure drops, and all the information necessary to do an analysis. One area that we are particularly interested in is the overall calculated heat transfer coefficient, which is given to us up in the top at 129.75 BTUs per hour foot square degree Fahrenheit. And this is important for us to know this so that we can use information from this if we want to try a longer heat exchanger and try to get more energy transferred from the hot stream to the cold stream. And finally, we have another menu popping up, and this is where we want to save our configuration by clicking on this. And all the information calculated by ChemCAD for this heat exchanger is now gone into memory. Next, we want to select our heat exchanger once again, and in this case, in the simulation mode, we want to select the double pipe simulation model. Note that all the temperature data for the various streams has been grayed out, and this is where ChemCAD will be using the information it calculated in order to determine what its predicted outlet temperatures are for the heat exchanger. After clicking OK, we run our program and look at our outlet streams again. Here we see instead of 145 degrees, our hot water outlet temperature is closer to 143.5, and our cold water temperature is now at 58.2 degrees Fahrenheit. And this is the ChemCAD prediction of how this particular heat exchanger would work under ideal conditions.